Our first topic for finals is about lateral loads on building frames. Okay, so first let us define what is a lateral load. According sa research na to sa Google, which is pinaka-basic na tong way to research, is that lateral load is a continuous and repeated application of a load on an object or structural component in a horizontal direction or parallel to the x-axis. Lateral loading can cause a material to shear or bend in the direction of the force and ultimately lead to the failure of the material. Okay, so isa pod nga maka-fail sa ato ang material, which is kinahanglan nato i-design ang ato ang structure to resist it, is ang lateral loads. So lateral loads are horizontal to the x-axis. So let us say you have a column, diba? So if there is a horizontal load which is opposite sa imuhang along the direction of the x-axis, so that is lateral. Okay, if na po kay beam horizontal gihapon, that is still lateral. So eventually, if you have the combination of beam and column, then you have a frame. Okay, you have a frame. So you have a force F which acts on the structure, horizontal force. So na-bending, di ba? Na-bending, mo bend siya. Padulong dito, padulong diri nga side. Pwede po siya makat diri, no, maputol. May failure nga mahitabo diri, maputol or mabuak or makat due to the shear force acting sa imong structure. Okay, so maka-cause gid siya og failure. So, isa siya sa mga kinahanglan i-consider for the structural analysis. So again, what are the example of the lateral loads? Okay, so muna to siya define. So example of lateral loads. So first, most lateral loads are live loads whose main component is horizontal force acting on the structure. Typical lateral loads would be a wind load. So one example, no, wind load against a facade. Say facade, kanang frontage bitaw sa imuhang structure ng front, or kanang mga billboard signages, di ba? Then an earthquake load, an earthquake. So ang earthquake na to, okay, kung naay shaking sa ground, that is, ang shaking is horizontal, which is along with the x-axis. So sa ato ang seismic analysis, natay shear force, eventually kani matransfer ni sa ato ang structure from, ni ba, ang load na to, the loads are transferred from up to bottom of your structure. Pero pag ang atong i-consider is earthquake load, baliktad po ang yung effect. So ang earthquake load is lahi siya, no, it will start at the ground, then ang load is transferred towards upward towards the sa imong structure. Pasaka siya ang effect sa earthquake. So earthquake load is an example of a lateral load. Pag nanamoy seismic analysis, you will still use portal and cantilever method in analyzing the structure. Okay, so another example pod is lateral earth pressure or earth pressure. So that is one type of Lateral load. So what is earth pressure? So earth pressure is, from the name itself, earth ang nag-cause og pressure. So may example na. Example is kanang mga retaining wall. So for example, na kay wall nga made of rocks. So kana siya sa purpose sa retaining wall to sustain a chunk of soil or ground laterally. So say for example kana nayuta diha na kay balay dire, example lang niya. So kana na kay lateral load, which is also triangular. Okay, mo push ang soil, ang ground mo push padulong sa imuhang structure, sa imong retaining wall, So example dire na kay napugay lahi nga structure dire. So para dili ang soil sa kani nga portion dili mo padulong dire. So na kay structure nga mo impede or mo pugong sa soil, sa ground. So ang resultant ani sa triangular loading, that is a lateral load. Okay? So klaro na?